Yo, 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 what's up? Let's see if we can implement some additional visuals to the water today. Make it look even prettier. And we're gonna start with... first of all, I just need to set the... Yeah, we don't have any time multiplier on this. Or do we? But it's extremely small, yeah. This one is rough as hell. Maybe not. Yeah, because it doesn't move as much over here. But this is still a problem, so I want to fix that first today. Same with this one, I think. Yeah, so this is another problem with screen space effects, I would say, when we try to fetch or we read pixels that are outside the texture. We get this elongation effect. Let's see if we can fix that real quick. So we need to check if we're outside the texture we want to go. I don't really know how to handle it though. So here, if we look in this direction, we can see that we're not getting any refraction here, because when we try to read the texture, the depth of the pixel we read is less than, so it's closer to the camera than the water surface, which means that we're no longer underneath water. So we can't pick that one, but so this is an artifact we get from the fact that we don't want the character to refactor or show up in the water refraction visuals. So I'm wondering if we just want to take if we get to a point where we try to read something that is no longer underwater, we try to reflect or refract in the other direction. So that would be down here, I think. No, here. So we're pretty much gonna have to do if this one fails, we would have to do this again, and this again. It's rough. How can we make that in a nice way? Yeah, and this one we want to rename. It's no longer an offset. It's UV scene center refracted. And this is not really refraction direction anymore. Refraction direction world space. Refraction position world space. Okay, let's just do it the ugly way first and see if we can clean it up after. So I want to do else here. And inside of the else, we just take all of this, put it here again. But we don't. So we calculate it again, and then we do negative refraction direction world space. So up here we do positive, here we do plus refraction direction, here we do minus refraction direction. And just try it again, but we refract it in the other direction. And then we get refraction here as well. It doesn't really look too good though. But I wonder if it looks... I think it's better. It's a little bit weird though. Now we get artifacts like this though. We could also try... We still do the positive refraction direction, but we do 0.5 times refraction strength. That probably looks a bit better, I would say. Not too sure if we have a solution for a problem like this though. Let's see. Scene texture, create scene texture. Don't we have clamp or something like that? Repeat. Repeat. Let's do render target handle. Unity. Yeah. Okay, that's not the one we want to do or use. So what do we have? We have render texture descriptor, but I don't see like repeat rules. Do we want to clamp? Do we want to repeat? Mirror repeat? I'm thinking of doing a mirror repeat, might be better. So this looks like a clamp type of artifact. I wonder if mirror repeat is better. So when we try to sample a pixel without or outside of the screen, we go in the opposite direction instead. So if we were to read this pixel, we read this pixel instead. But where do we have that one? Render texture descriptor, okay. Yo, what's up, David? I haven't been here in a while, but I'm happy to see that you have made constant progress on your game. Good luck, mate. Thank you, appreciate it. Appreciate it. I find it extremely weird that we don't have descriptor dot use mipmap mips volume depth bind. No. Flags graphics form. Oh yeah, 1 sec. Shadow sampling mode. I would like to, what I'm trying to find is texture 2D Unity. I'm trying to find the equivalent of I'm trying to find the equivalent of this one, wrap mode. Extremely cool that you can have wrap mode UVW, that you can have different wrap modes per dimension. But let's see here. Yeah, I'm looking for wrap mode. Render texture descriptor doesn't seem to have it though. Do we have something here then? Scene test target handle dot identifier dot wrap mode for that's too bad. An idea might be to use a sampler that confirms the wrap mode you want to use. Oh yeah, we're gonna have to declare custom samplers in the shader. Yeah, that might be a way to go. I definitely want this feature. Maybe, so this is back in 2018, but then still not an option 21. Let's see here. Unity HLSL custom or sampler wrap mode. Using sampler state wrap. Here we go. Yeah, so it's just about how we name them, and then we need to do this as well. But I don't want to sample textures like this. Fuck. In some of our shader, in one of the shaders, we're using a custom sampler. I just can't remember which one it is. So I guess we would have linear. Thought this one would be bilinear, but okay, so if we would be doing this, we would call it scene texture mirror, or actually scene texture linear or point. Scene texture point mirror sampler. Would love to be able to set it just here instead, but Yeah, we're gonna fix this one as well. I know a way to make this pretty. I just want to fix this mirroring first of all. But maybe we could fix it manually by doing... Yeah, we could probably do it like this. UV scene center refracted. We could do... Yo, good morning, Harukanan. We could probably do... We could do it in an ugly way by doing... Or actually... UV... Yeah, we could do it like this. If UV scene center refracted. Let's see if we get a good result of this, or by doing this. So we're gonna do a manual mirror instead. If we do get a good result from it, I'm probably gonna try... Then we're gonna read textures using this instead, and we're just gonna have to add a note, or I'm gonna create an issue on GitHub. Because by doing this, by using inline samplers, we're limiting us to this rule. Or we're we limit us to this. That's not preferable, but UV scene center refracted.x, if this one is bigger than 1, or less than 0, can we fix it? Actually, let's do it like this. Else if, and then we do an if. One sec. Util math. Don't we have clamp mirror? If t is less than 0, we do abs t. If t is bigger than 1, we do this. So we can do UV scene center refracted is equal to float to clamp mirror dot y. Yo, what's up, Anton? Manual should work fine. Like doing it like this. But I mean, I'm against it, but purely for the fact that this functionality does exist in sampler states. It's just that we can't set it on a temporary command buffer render texture. And if we use inline sampler states, it's gonna, like, this adds... I wonder what, like, how much performance do we lose by doing it like this compared to having a proper sampler. I guess sampling is, I'm just spitballing here, but sampling could probably be hardware implemented. But let's see, let's test this one. So basically what we do here, if our UV scene center refracted coordinates are outside of the screen, then we mirror clamp them. So if it's below 0, we just do absolute value. If it's above 0, we take 1 minus modulus, I think. Let's see what we get. And then it looks like this instead. I don't know. Yeah, that's probably much better, honestly. So that hides. Yeah, that's much better. Jesus. Yes. Okay, so this is not good. And it's true. I would probably much prefer this over what we just had. Yo, what's up, Geralt? Good morning, good morning. Awesome job, sir. Looks so great. Thank you, appreciate it. Yeah, I think so as well. Nah, I probably prefer this, honestly, as opposed to mirror ones. Procedural water terrain material, what do we have? Yeah, this is extremely rough, but I think maybe we can fix it by doing so much the similar we do here. So we do let's see here. And so the idea here is we refract and then we check if we're still underneath water. If we are, set the UV center to the UV center refracted. If we're not, we try to refract a tiny bit less. And we do a lot of stuff twice here. So this is definitely high fidelity water, so we're going to limit it to that shader variant in the future, and we're going to clean this up a bit. But when it comes to, let's see if I can get, okay, here, let's see, here. So this is probably worst case scenario for texture clamp read mode, when we get artifacts like this. And I think we can minimize it a tiny bit by doing, let's see, util blend, util helper functions, math. I wonder if I want to put it in util math. Yeah. Bool in bounds or within bounds float 2 p min float 2 max. Return p.x is bigger than 0. p.x is less than 0, or p.x is bigger than 1, or p.y is less than not 0. We want min.x, max.x, min.y, or p.y is bigger than max.y. And then we put all of this within parentheses and return this one. So if this is true, if any of these are true, then we return false. So we can do if this, let's see, I just have to see how this looks. Okay, this one. And then we do, so if this and within bounds UV scene center refracted float 201 float 201. So if it's not within bounds, we refract with half the water refraction strength, which removes it a tiny bit, and then 25 refracts it even more. Yeah, so still we minimize the artifact, but one sec actually. Whoa. Okay, now we have a lot of refraction. Now we don't. Okay, so this one fails for some reason. UV scene center refracted. Oh, 0, 0 and 1, 1. That's what we want to do. Not too sure about that one though. Yeah, now we minimize it a bit. We get this, however. I don't know if this is that much. I don't know if this is better or if it's worse. Nah, I'm pretty sure we're better off without it. Hmm. Harukanen, this is fine, not even 1% will notice it. I would, but I'm a game dev, so yeah. Yeah, I know how that is. It's fine, it's fine, it's fine. But just to find some cheap way to minimize it would be amazing, but yeah. When it comes to screen space, screen space effects, you usually see artifacts like this, so yeah, it's fine. I agree, I agree. Mm. Anton, do you already try to lerp 0.9 to 1.1 as 0.9 to 1? Not entirely sure I understand. Do you already try to lerp 0.9 to 1.9 as 0.9 to 1? Harukanen, a post-process scale-up would get rid of it, but that is just, nah. Yeah, I know, it's fine. Like, artifacts like these, you see them all the time in AAA titles as well. So, but this, like, the bottom line artifact flickering you get while running like this sucks. And I mean, the mirror one, you get the same effect. Oh, Anton, maybe I understand what you mean. Do you already try to learn 0.9 to 1? Ooh, yeah, maybe we can do. That is true. Oh, I get it, I get it, I get it. Yes, I get it now, I get it now. Yeah, maybe we can do something like that. Oh fuck, that's a beautiful idea. Let's see what we get. How do I want to do this and where do I want to do it? What's up, Scooby Snacks? Okay, so if we're at the edges reading values, so yeah, let's say between 0.9 and 1, we want to stretch that out. We don't want to make it. Yeah, so we might want to make we want to remap the 0.9 to 1.1 to 0.9 1.0. Right, we want to do a remap. Oh, that's very nice. Yeah, we can try and do it in a semi-dirty way. So UV center refracted. If let's do it like this. Scene refracted.x is bigger than 1. Is less than 0. Dot x is equal to, I think we should have remap here. Do we remap? Or actually, you have remap, don't you? HLSL remap. Oh no. Oh, this one, yeah, it's a pretty wall of text indeed. I thought we had a remap within here. Inverse slurp, interplate, clamp mirror, tangent. Okay. It's pretty much just in this one we want to implement. Min 1, max 1, min, yeah. Yeah, let's go with value here instead. So we want to do terrain, procedural water, but we want to do if it's bigger than 0.9 or something, right? And if it's less than 0.1. Remap. And we want to remap it from 0.9, 1.1 maybe, to 0.1.0, something like that. And here we do minus 0.1, 0.1. something like this, right? And then we need to do the same for Y. We get another, like, this is actually pretty good. It obscures us a bit. We get a little bit of another artifact here, but I think this is definitely better. I think. And then we can alter these values in such a way that we might minimize it even more. This is rough. We have a lot of flickering. Oh, I like this. Fucking beautiful idea. Thank you for that one, Anton, by the way. Really appreciate it. I do very much prefer this artifact over the other one. And we can alter this one. Let's see if we can make this look nicer, though. Mm. maybe just create a clamp. There must be a nicer way to write this, right? Yeah, we can probably do... Yeah, can't we put these... If it's bigger than 0.9 or less than 0.1, then we remap from minus 0.1 from this to this. That's one way to simplify it, right? Or no. Oh, okay, definitely not. Because this one, yeah, of course we can't simplify it like that. Yo, what's up, Diligence? Yeah. Appreciate it. If we can just hide this in a function, I'm fine with it as well. Although I'm not entirely sure how I want to define that function. Scale edge values or something like that. And then we do error of margin, scale edge values, util math, float scale. Max, and then we do if value is bigger than max minus offset, or if value is less than min plus offset. And then we do return value. Oh, what the fuck? Shouldn't we be able to do if value is this and this, return value, else, right? So if value is less than max minus offset and this one, otherwise return remap value Oh, we need these values again, right? This one and this one. I just want to see if this one works first. So if this is not true, then we do a remap. Now I'm still overlooking something. Fuck it. Let's keep it simple, straightforward. So if value is bigger than max minus offset, then we to wow, remap this value, remap value from max edge to max plus offset to max edge and max. Otherwise, this pretty much obscures it a lot, but minus 0.1. Negative min edge. Min edge. Min edge. Scale edge values, remap. Creature collecting game, question mark, kind of like Pokemon, right? Chow Garden, Tamagotchi, Viva Pinata. I heard Nintendo patent creature collection. We gotta be real careful. It's a gray area, I've heard. Remap edge values. Is this what I want to do? It just feels like I've obscured it quite a lot. So let's say that we have a value. We have, let's say max is 0 or 1. 0, 1, 0.1. Then we get 0.9. So we take the value from 0.9 to 1.1. Zero 0.9, 1.1, 0.91. That's what we want. Yo, what's up, Cooler SK, by the way, and JDD, if I can call you that. Yo, hope you're having a fine day. How to kind of just do like everyone else does when they create sketchy crap. Start a rainy day fund for future lawsuit stuff. Yeah, you might see. What is it? Kickstarter? Is that still the go-to? Yeah, I might put up a Kickstarter law fund soon. Be on the lookout. Let's see if we get the same result here. So basically, what we want to do is UV scene center refracted is equal to not clamp mirror, but what did we call it? Remap edge values. 0 min max offset, so 0, 1, 0.1. 0, 1, 0.1. Am I missing? Oh. Undeclared identify remap. What's wrong with the remap? Oh. We're still playing by the old rules that it needs to be declared before it's used. Like, that's good. Okay, that's good, that's good. I'm wondering, we have a little bit of a shadow artifact here as well. That's a bit too much. too bad. Okay, let's see. Remap edge values. Let's do a remap edge. Float. Remap edge float. Remap edge float 2. Oh, come on. Remap edge float, remap edge float 2. What am I missing? Unexpected token float. Fuck, here we use F syntax, so might want to rename it, but I want to get... So what is this? Syntax unexpected token float 38. Oh yeah. Okay, good. Good. And let's do... Yeah, let's rename this V here to an F. And this V2 to an F2. And then we're gonna add a property so we can control this offset. Make it less and more, and maybe... Do you want to base that on camera angle or something like that? I don't know. Let's see. Water refraction. Water refraction edge. edge remap offset. Water refraction edge remap offset. There's no way, like two weeks from now, there's no way I'm gonna know what this one actually is. But we're gonna have a default value of 0, and then we're gonna use this one. Down, 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 down here. So instead of this one, we put water refraction edge remap offset. Should we keep this one behind any type of fidelity level of the water? I don't think so. That it's really not that much extra calculations. But let's see. So now it's 0. Now we could see. So here we can see the clamp work. Looks like this. We get a lot of flickering. It's not that good. And if we change it to 0.1, we don't get any difference. Because I'm changing the wrong material. So we want to change it here to 0.1. So we get this warp effect instead, and I think I prefer warp instead of flickering. We can adjust it so it's 0.05 to make it somewhere in between warp and clamp. Or we could put it at 0.2 to make it really warpy. But yeah, 0.05 is probably correct. Ship it soon. Row it soon. And what we're seeing here is we're getting, it's a little bit more blue here, or less alpha, or more alpha value, a higher alpha value, because it's deep here, but it's still, honestly, it doesn't look that good. But this is a problem I'm just gonna keep it at the back of my head, because we might be able to minimize it later on when we actually handle the surface. So right now we're just doing below water surface stuff. Only have these two left. But before we move back to this one, which I'm still skeptical about, if I will be able to implement it in a nice way, we're gonna do one more refraction fix, and it's the one at the edges. So it's the part here. I want to clean this one up. Robert Pattinson, now let's add realistic wave system. Maybe in the future. So I think I want to hide this one in a, I think we're going to do it like this. While okay, this will screw something up, but while do while some variable is less than iteration variable, or in fact, I don't even know, do we have HLSL do while loops? Do we have these at our disposal? Yeah, beautiful. Because what I want to do then is something, let's see here, something like this. Maximum quads per, so if the fidelity is high, we want to do something. If it's medium, we want to do something else. Or we want to define, let's see. Actually, I would probably want to have these constants defined down here, because then we can put, I don't know. Let's do it like this. Water fidelity. So basically what I want to do here is, so we refract if the refraction doesn't work, or like if we're reading something that, if we're reading a value that is not available to us, not because it's outside of the screen, but the pixel we're trying to read does not conform to this statement, then we want to try to refract again, but we want to do it with less refraction power. I wonder if there's a smarter way to do this. So pretty much first we refract with water refraction strength. If that doesn't work, we refract with 0.5 water refraction strength. If that doesn't work, 0.25. If that doesn't work, 0.125, and so on. It's a brute forcey kind of way to do it. There might exist an approach where we can calculate a new refraction multiplier using these two. So if the first refract doesn't work, with how much are we off? Nah, it's a very special case. variables defined within a do statement, we keep them on the outside? Because we're always doing this one once. Are they stuck in the do while scope, or do we actually have them on the outside? Okay, let's see. Do while false. And then we do oh, they are. Okay, beautiful. That's nice. Beautiful. 'Let's do this. Okay, we definitely don't want to leave it like refraction success. We don't want to leave it like this. But do this until this one is true, or until this one succeeds, and then we do this if we have a success. But we want to add some extra check here. Define maximum refraction tries. Three, two, one, I'm thinking. 3, 2, 1. And then we do refraction success int refraction tries is equal to, I want to set it to 0. And the last thing we do here is refraction tries, increase it. So while refraction hasn't succeeded and refraction tries is less than max refraction tries. So it's 0, we do it once, then it's 1. If water fidelity is low, then this one is 1. So this one is false, so we don't continue. Or if we find, or if we have max fidelity of the water, or high, then this one is 3, so we do it 1, continue. If this one fails, then, and then we do 2, continue, then we do 3, and then we're done. But if this one is set to true, previously we exit. So something like this. And honestly, if we just take a quick look at what's involved in one refraction try, it's a whole lot of math. And then we have one sample texture and one sample scene depth. Let's try it. Am I gonna break something? Oh, could it be? Yeah, okay, so we don't have these on the outside, it's just that we never use them. Okay, good to know. I thought it was weird. In fact, do we want to put this one? Yeah, we probably just want to do this one in here, honestly. Yeah, I don't know why I put it on the outside. Oh yeah, I forgot to do one thing. This one, we never... Yeah, so refraction tries, we want to do float refraction strength is equal to pow 0.5 refraction tries. So first we get 1, then 0.5, 0.25, 0.125, and then we replace, but we want to multiply this one with water refraction strength as well. Yeah. We get just... So we get like a layered artifact here. But honestly, if we compare this layered artifact compared to if we would do... Oh, do we actually call this one grass fidelity? One sec. Performance water. So let's see if we can get high and low here. So now we get layered refraction. We can see here line, line, line compared to this. So with low refraction, we don't get any refraction at the edge here. But I wonder... Would it be better to alter this one? No, 15. So this is low. This is high. This one looks better on high as well, I think. So it's a steep angle fix. Check this. Look at this compared to this. It's not correct, but I think it's better. Okay, so that together with the lerping without outside here, thanks to you, Anton, leaves us at a pretty good position when it comes to refraction, I would say. Definitely. And I hate channel swap shader. Yeah. Redefinition of pi. Can we do Yo, what's up, Crazy Gamer? Welcome back. Can we do this? Beautiful. And what do we have here? Array reference cannot be used in an... I just want to get rid of these. Fuck, we're gonna have to do it like this. Color float color array is equal to float for color.r, color.g, color.b, color.a. And then we do color array, color array, color array, color array, and then we return float 4, color array 0. So this is very much, this is not related at all to the water shader, but I just don't like, I don't want to continue with an error here. 55. Fuck, how do we want to do this? Oh, float, new float. Is this the syntax for it in HLSL? No. HLSL declare fixed size array. Float for color array. Can we do it like this? Unexpected token 56. What am I missing? Float color array 4. Yeah, that's how we want to do it, right? Yeah, there we go. Okay. No warnings, no errors. Good. Good, 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 good. Yes, before we continue, I'm just gonna commit this. So I want to commit, not this one, I can wait with that one. But I want to commit util math. And terrain procedural water. So I've done a lot of stuff here. Just refraction fixes though. And yeah, before I commit it, I want to remove this and the chromatic aberration flag as well, because this is what we're gonna do next. So just give me a sec real quick. Util math. So what functions did we add here? We added within bounds, remap edge, float, remap edge, float 2. To util math. Okay, that's that one, and then I want to add, or I want to commit this one as well, but I don't want to commit it with aberration flag. So we're gonna remove this. We're gonna remove this and this one. Okay. Improve refraction fidelity, or improve refraction fidelity by obscuring screen space related artifacts. And this one is related to, let's see, what's the issue? 35. Okay, there we go. There we go. Anton, good stuff you're doing here. Unfortunately, should go do some work, have a productive stream. Thank you so much for watching, appreciate it. Thank you for the tip as well, the interpolation and the kind words, and good luck with your work. Okay, now we have committed this, so let's jump back to this shader and let's add this one back, and this one back. One thing though, I'm not a very big fan of, so when we do shader feature here, I usually do it, name them in all caps, because that seems to be somewhat the standard. This one, the naming of this one sucks right now, so we're gonna do, I wonder if we can do isn't there a Windows shortcut making all letters capital? To keep between lowercase, uppercase. Select the text and press Shift F3. Let's try it. In this case we would get, let's do this. Shift F3. Okay, so is that just for Shift F3? Didn't really work, but let's just do it like this. Chromatic aberration. That's not how we spell it. Flag. Okay, let's see if we can possibly implement this in a nice way. We're gonna focus just on the scene color for now and not the outlines. See if we can make it work. In fact, this is beautiful. Okay, so the idea is that we define these methods. If this one is not enabled, we're just going to sample the texture as we usually do. But if this one is enabled, I want to add something like this. I want to try one thing. Chromatic aberration, here we have it. Yeah, then it doesn't work. I'll switch back. Okay. UV0, UV0. Because I'm thinking we're gonna make UV. So if we have chromatic aberration enabled, this one is gonna be an array. If we don't, it's just gonna be a float 2. And it's gonna be the same for this one, I think. Yeah. So we're gonna have this one, this flag, we're gonna have it in 3 different places, I think. We're gonna have it here. Or one sec. Can we reduce the number of... Could we add some extra variables here? Yes, I think we might be able to... No. Or... Oh yeah, so here we're gonna return float 4. Oops. There we go, I think. So sample scene color for this one takes 4 UVs because we sample each each channel separately, and here we just sample one, or we sample all the channels in one go. sample scene color. Let's see here. Sample texture 2D LOD. Outlines. We just have outlines, outlines, outlines. Then we have color here. Scene texture. Fuck, do we not... Don't we actually have... Okay, so here we have scene texture. And here we have scene texture. Color, okay. So first of all, let's try, yeah, 284. Oh yeah, we need to do .r, .g, .b, .a, .r, .g, .b, .a. Could probably do this without the alpha channel eventually. I don't think we really care about that one. But where were we? Do we get an error? No, none. Okay, now it's cool. Good. Welcome back, Redstone, and hope you're having a wonderful day. And it's going pretty good here. So this morning so far we have fixed some issues or some artifacts with the refraction, so that's good. As to your second statement, two things. 0.351 cents is better than 0.0 cents. But more importantly, correct me if I'm wrong, they might have changed this, but my account is currently affiliate at Twitch, which means that I have to run ads, and if I don't have around 3 minutes of ads each hour, Twitch is gonna add a pre-roll ad to my channel, which means that like every time someone enters it, ads are gonna play, and that's just a real good way of scaring away new watchers, right? So yeah, this is how we do it. Okay, let's see if we can get this chromatic aberration to work. Somewhat work. Chromatic aberration. Let's add a space here, just make it look a little bit prettier. Chromatic aberration constant. Or constant might not be what we want to do, but strength. And I want to make it into a range between zero and 1. And by default we're going to go with 0.0. Water refraction. Okay. So I think we want to do UV scene center here. If this one, else, and if. So if this one is true, or if this one is not true, I'm gonna put this one here. So if it's not true, we're gonna have a UV scene centered that is a float 2. Although I wonder, yeah, if it is true, we're gonna have a float 2 UV scene center 4. And then we do UV center 0 is equal to UV scene center 1. I wonder if we can do it like this. Which is equal to this. Okay. It's this one we want to change based on so refraction direction. I think we're going to put all of this in a separate function. I think. Fuck, we need to put this one as well. Whoa, one sec. Yeah, we don't use this one, that's good. I don't think. $347. question is, do we need I don't know just yet if we pixel outline data. Yeah, for now we're just gonna do this solo-ish. So we want sample outlines as well. So we're gonna do sample scene color LOD, float 4 sample outlines data, float 2 UV4, and here we have float 4 sample outline data, float 2 UV. Pixel outline data, so what we want to return is this. In fact, we need LOD as well. Yes, we do. LOD, yeah, because we have this one. Okay. How many lines are we at total now? 500. Not too bad. Sample outline data. And we want to do the same thing here for now with UV scene or UV 0. We're just going to take the first one here. Here we just want UV, UV. And here we have UV 0. Chromatic aberration, normal. Okay, so now let's go through it and remove all of sample texture 2Ds in our code. And that's quite a lot. This one we don't want to replace, but this one we want. Pixel outline data. So sample outline data UV scene center. Right. I think it's gonna look a little bit prettier here as well. Oh, I want to fix this one as well. So sample outline data. The only time we use pixel outline data and don't read G is, let's see here. Here we read outlines as well. Data distorted, but we just use G. Sample text, here we read outlines, but we just use G. The only place where we don't do it is here. So probably want to obscure linear eye depth, or getting this one as well. So float sample linear eye depth. Sample scene linear eye depth and sample outline linear eye depth. In fact, this one stands for, yeah, we're gonna get close to 100 lines just for chromatic aberration setup or definition methods. That sucks. Oh well. UV4. UV4. Okay, so linear eye depth, sample scene depth, this one. Return. And then outline linear depth, here we're gonna do return, but here we do sample outline data .g. But first we want to do sample outline data UV sample outline data UV dot G. Okay, let's see here now. Linear eye depth. Sample scene. Linear eye depth, UV scene center. And pixel outline data. Is it this one we use down here? Yeah, we use it here, so we're probably just gonna put this one to here we use this one as well. That's true. Outline data, which we read here. Yeah, here we probably want to go with the data, definitely. But okay. Pixel scene depth, or we're gonna leave this one here for now. Or actually, no. Let's do it like this. I'm gonna add a method up here that converts something to linear eye depth. Float. Linear eye depth, float, depth. It's just I wanna hide this one basically. Depth. Oh, 310. Oh, This is the worst part with shader variants. This it's not going to be true anymore. So where do we have sample texture LOD? Oh yeah, sample outline data. Sample outline data, return. There we go. Crazy Gamer. Okay, my tutorial also completed. Need to watch one more playlist. I might be able to build half working on my first game. Nice. But creating a touchscreen joystick is just on another level. You will get there. You will get there. Ooh. One sec. Okay. Let's continue whatever the fuck this is. So, pixel outline data, sample outline data, pixel scene depth. Here we just send in this. Pixel outline depth. We just send in this. What do we do then? Refraction. Yeah, we're gonna have to do stuff here soon, I think. Pixel outline data distorted. So here we just want to do sample outline data. Pixel scene depth distorted. So here we just do sample scene depth. Okay. Chris Gaming, your game is just fantastic. Thank you, appreciate it. It's starting to look real good. Okay, here we sample texture LOD, so pixel outline data. Sample outline data, UV scene center outline kernel level, pixel outline depth. One sec. Pixel outline depth. Why do we redefine it here? Okay, what did I screw up here? Sample texture 2D outlines. Sample outlines data. Okay, so this one. Sample scene depth. Oh, UV scene center refracted. Yeah, this is scene depth. Sample scene depth. What? Sample scene linear eye depth, yes. Ooh. Oh. What is it? Sample scene linear eye depth. This one we only use for G, right? Yeah. So depth, let's call this one sample outline linear depth. Okay, looks good. Here we have pixel outline data again. Sample outline data. Okay. And then we have color here. Sample scene color. Then we do a lot of blurring here. Depth. So this is just scene depth. UV scene sample scene depth. Then we have outline data and outline depth. Outline data, what do we use this one for? Fuck, we use it here. Okay. Sample outline data. And then we sample scene texture here. Sample scene color. Okay. Okay. Okay, so now we rely on these methods instead. So we have a set of methods for chromatic aberration, and we have some for when it's disabled. So UV scene center, when we define this one, when it's chromatic aberration, it's an array. Otherwise, where do we use this one now? UV scene center, we use it here, we use it here, so that's okay. We use UV scene refracted here, so we're probably gonna have to do an if else here as well, which, let's see if we can make it in a nice way. Sample outline data, here it's okay. Sample scene color, here it's okay. Oh. Yeah, we're gonna have to do methods for these as well. Yeah, the blurring really fucks this up, honestly. UV scene, UV outline. So these two we need to handle as well, but then we should be okay. Okay, so these two, so UV offsetting and this refraction here, which is pretty much also only UV offsetting. Yeah, so it's this code, this one, UV scene center refracted, we need to calculate this one on the outside. That's okay, I think, because we can create a method up at the top where we have our compiler flags. So calculate because we don't use this. Yes, we just calculate one method that calculates a UV scene center refracted, or just call it refract. We need this one. Yeah. Yeah, so we just create a method that takes, called refract maybe, which takes a UV scene center coordinate. And then we call this one here. But oh, okay, we use it twice here. That's true. So we do need to store it. But, okay, we could probably put... I wonder if we can put all of this... Yeah, we can. We put all of this in a method. Let's see here. If HLSL ref argument parameters input only, input and out, in out. Yeah, maybe we can do an in out here. So we create, this is, I think this is good. Fuck, there's a lot of methods here now, but it would be nice if we could simplify it a bit. But what I want to do is float, refract, or actually, bool try refract, float 2 UV. No. In out UV. Try refract. Unrecognized identifier UV. Oh, is that because return true? In out float 2 UV. Sample scene color. Sample scene color LOD. Okay, beautiful. So where do we have refraction? Here we have it. If we take, yeah, let's just take all of this for now. And put it tri-refract in here. So we calculate refraction strength. We need to send in tris, but we're gonna call it int I don't want to call it refraction iteration. I want to call it refraction exponent. So we calculate refraction strength, refraction direction in world space. Yeah, then we need view direction and normal. We need position in world space as well. So float 3 view direction, float 3 normal, and float 3 position world space. So view direction world space, normal world space, position world space. We need scene water depth as well. Now we should have everything we need, and then we do so if this one is big, pixel depth, fuck. Yeah, so here we set UV is equal to UVC center refracted. And then we return true here. And here we return false. I wonder if it's going to complain that we haven't set this one. But, let's see. So here we do refraction success is equal to try refract UV scene center input dot position world space, view direction world space, normal world space. What is it? It's scene water depth world space. That's just scene water depth. And then we have refraction exponent, which is refraction tris. And finally depth threshold, which is pixel depth. And then we increment this one as well. Oh no, did I, what do I try refract in out? What have I missed? Hmm. Okay, it still looks good. Or actually, like it looks like it did, so that's good. So, now comes the hard part, I think. Because now we would like to implement this one here as well. Try refract. This one we want to keep as first of all, this one we want to make into a UV4. Refraction strength we want to keep. Refraction direction, this one we want to create 4 of these. And then we want to create 4 of these. And 4 of these, and 4 of these, and so on and so on. So I wonder if we want to do it with a for loop. Probably. One sec, I'm just gonna check real quick if the blurring still works. Do we have that much of a bleeding? That sucks. Did we have that much bleeding previously? I don't know. I think I've fucked up the blurring. Have I? Okay. Okay, we have some issue with the refraction and blur. Yeah, definitely. But it's okay. Okay. Try refract for this one then. Probably want to do it with a for loop, I think. Refraction strength is unchanged, everything else. So this one, this refraction index is going to be different per channel. So this one affects this one, which affects this one, which affects this one, which affects this one. Crazy Gamer, you are so detailed in your work. Yeah, I am. Sometimes it's a good thing, sometimes it's not. So we do it like this. Bool success. Okay, so now I think like we're gonna do this. So for red channel we want to use one water refraction index. For G channel, green channel, we want to use another, and for blue channel we want to use a third one. I think I'm gonna rely on this one, chromatic aberration strength. So we're gonna do float water refraction index is equal to water refraction index plus I minus 1 times chromatic aberration strength, which means that, okay, so if we're at 0 here, we get minus 1 here. So we get this minus this for the first one. For the second one, the green channel, we just get this one because this one is 0. And for the third one, we get this plus this. And alpha channel, we're just gonna put it to be equal to whatever we had, yes. So then we call this one, but we do it with this water refraction index. And then we do this. And then we do these. At the end here, we just want to return success. Success is equal to true. So if at least one channel succeeds, then we're gonna call all of it a success, and we don't care about. Yeah, one has to succeed. Or maybe we want all of them to succeed. That is true. Succeed. UV scene. Okay, so here we do UV I is equal to this one. So we fill up UV 0, 1, 2. I think this is what we want to do. So down here when we do try refract, so this one we're working with a UV scene center array here. So we shouldn't be getting any problems here. So this one should be okay right now. I want to see chromatic aberration. Sample text to the LOD, too few arguments. And 310. Yes. Sample outline data cannot implicitly convert from float 2 to float 2 array. 323. So here. Sample scene linear eye depth 339. Okay. So this we bring out here, because this one actually needs to be an array as well. Or not really, not this one, but this one needs to be. This is how we're gonna do it. We're gonna utilize, do I have one of those? Average. I want to do float min, float 2 f2. Let's add one f2 here as well. So minimum return min f2.x, f2.y. Float min float 3. Whoa, whoa, whoa. So just three methods. So given a sum vector, we find the minimum, average, and I want to do a maximum as well. Okay. Because then we can do UV scene center refracted. Let's do float 4 UV scene center refracted. So this is going to be a 4, and we want to do UV scene center refracted 3 is equal to UV 3. UV scene center refracted. So here we do I is equal to oops, I. So then when we have filled this one up, we want to set this one to be true if the minimum value of UV scene refracted no yeah, float 4 actually we just get floats here. That is true, because we just used the first one here. Okay, so for now we're gonna keep it like this, but in the future we're probably gonna use the min-max methods here, I hope. But yeah, so this one is a float 4 array. That's not what we want. A float 2 array. And we don't need success anymore. Something like this. Util math 63. Float 2. Float 240, float 2 at line 347. Mm. 485. Okay, now we're further down. Invalid subscript X. It's this one. The offsetting here, which was the next problem. So this one we need to fix. Blurring. Yeah, we're probably just gonna do. We're probably just gonna do a. An offset method where we send in X offset and Y offset. Try refract. Yeah, maybe it would be cleaner if we just remove this one and this, or this one and do LOD on all of them. Just get some space. maybe doing an in-out would be best in this case. Let's see here. So we can do this. Or actually no. Float to UV offsetted. Offset UV, offset UV. UV scene. UV outline. One sec. Okay. Some scene depth. Fuck, I still want to define these in here, or yeah, but I don't want to add an extra compiler flag check like this. So I'm wondering if we want to instantiate them up here, but that might be a bit weird. This one we use twice, that sucks. Fuck it, I think we can just do this. UV scene, UV outline. So we do float 2 offset is equal to float 2 x times scene texel size dot x and y times scene texel size dot y. And then UV scene, UV outline. So we offset UV scene center offset. Here as well, and then we can again remove this one, right? And then we do the same with this one. We only do it here, so oh, one sec. Yeah, it's the same. Oh, is this something left over from outline textile size? That is true. Scene textile size, outline textile size. So scene UV offset or UV scene offset. Outline textile size UV outline offset. Is that it? Cannot convert from float 2 to float 2 at line 358. Oh. Is that so? Okay. But if we do in out, but we don't want to change this one. Okay. Actually, using a struct might clean up a few things. We can probably hide this one. Just create a method that returns a UV struct. So we define one UV struct in here and one UV struct in here. Yes. Yo, what's up, Diligence? Again, what's bugging me? That I can't return arrays. Sorry. That I can't return arrays from functions in HLSL, but it makes, yeah, I buy it. It's a little bit weird that you can't return fixed sized arrays. But okay. But we can probably clean this up. Okay. So let's jump back to this one. Disable chromatic aberration. Does this look? The normal artifacts here actually makes it look even better, I think. Okay. So let's define let's see here. So it would look something like Cool. Okay, let's see. So struct UV RGBA floats 2 Is this how I want to do it or name it? UV I don't know, maybe. How do we do here? UV scene center refracted. This. Not entirely sure about the naming I chose here. I'm probably gonna do some renaming tomorrow. But does this work right now? Read the definition of float 4, 365. Renaming of float 4. Are they redefinition of float 4? Are they serious? Diligence naming is the hardest thing in programming. One of them at least. Redefinition of float 4. What the fuck? Oh, do we need to do a semicolon? Yes, we do. Sample outline data cannot convert from float 2 to struct 2D. 386. Diligence can't wait to beta test it. Not sure my PC can run it with those graphics though. What graphics card do you have? Definitely gonna try and make it so that it can run on as many machines as possible, but still keeping it sorta high. A sorta high visual fidelity. RTX 2060 laptop. 2060 compared to RTX 2060 compared to I guess we could check benchmarks, but yeah. It's a little bit worse, but not much. I appreciate the joke, but I take this optimization stuff really serious. Cannot convert from float 2 to struct UV at line 386. What you want? Oh yeah. Oh yeah. $399. Sample outline data, UV scene center. Oh yeah. Okay, so this one, we're gonna need to clean this one up by doing some sort of instantiation methods. But I think it's good. Unfortunately, I won't have the time to do it today, but it feels like we're very close to actually testing out the chromatic aberration. And I'm a little bit nervous. I'm not so confident that it will work. But yeah, well, still good progress today. Refraction is working really good. We have hidden most of the artifacts as well. So yeah, let's continue this tomorrow. And as always, thank you so much for watching, everybody, and have a great rest of the day. Peace.